Welcome to this episode of Eyes on Earth. We're a podcast that focuses on our ever-changing planet and on the people here at Eros and across the globe who use remote sensing to monitor and study the health of Earth. I'm your host, Steve Young. Today we are visiting with Dr. Marvin Bauer. Marv is a professor emeritus of remote sensing at the University of Minnesota and the longtime editor-in-chief of the premier remote sensing journal called Remote Sensing of Environment. We're going to talk to Marv today about science's place in our global society. Science is coming under a lot of fire these days, whether we're talking about climate science, medical science, even science in general. Marv knows a lot about this stuff. He received the 2010 William T. Pecora Award from the Department of Interior and from NASA for his pioneering research contributions and his expertise in the remote sensing of natural resources. In his Pecora citation, Marv was credited with directly improving the credibility of remote sensing science through his work as editor of Remote Sensing of Environment, as well as his work in ensuring the timely publication of the highest quality remote sensing papers. Welcome, Marv.
Steve, thank you for inviting me.
What made you decide to take on the role of remote sensing of environment?
From its beginning in 1969, RSE has been about quantitative biophysical sensing with electronic sensors and digital image processing classification for monitoring and analysis of environment and Earth resources. People over the years, starting in the 70s, really began to recognize, yes, scientific journal publication is really important to the field. And RSE became the journal they began to look for hey, there's where a lot of good papers are. When I became the editor-in-chief of RSE in 1980, I thought it was a way I might contribute to remote sensing research and applications beyond my own research.
So talk about peer reviews in remote sensing science. How critical are they to the legitimacy and value of science that's being done and its applications? And why? Tell us why.
My observation as a researcher as well as editor is that science is not advanced by publishing weak papers. Rigorous peer review is the hallmark of scientific journal publication. It's absolutely critical to evaluating the soundness and validity of research. Reviews assist editors in determining whether the contribution and merits of submitted papers meet the journal standards and are sufficient for journal publication. They also help authors improve their papers and strengthen their research. There are very few papers that cannot be improved by revision following review. Best authors expect and appreciate critical evaluation of their papers. It takes time and effort by the reviewers, and it's not always as fast as authors would like, but I will suggest it is more important to get it right.
So people are reviewing the work of their colleagues. Are those peer reviews blind?
Most journals use a blind review process. I do not see much, if any, advantage in identifying reviewer names. I suspect it would discourage many reviewers from agreeing to do a review and providing their candid thoughts.
I assume authors sometimes resist criticism from reviewers. How do you handle difficult authors or difficult reviewers?
I found the best way to avoid criticism of reviews was to select reviewers whose experience and research interests were well matched to the topic of the paper. Most authors expect serious reviews, but they may also disagree with some points in reviews and rebut them while revising the paper. Criticisms need to be taken seriously. If a paper's been rejected, it's actually okay for an author to request reconsideration. I never thought my decisions were infallible, and sometimes a paper that was initially rejected is not only accepted, but well cited, a positive outcome. Other times, however, we decide the initial decision was correct. And it goes without saying that authors are essential to any journal, but so are the reviewers. The difficulty with reviewers is that given their other demands in their time, invited reviewers don't say, yes, I'll do it as often as would be desirable. And even when they do, are sometimes slow about submitting their review, seemingly forgetting that as authors, they'd like to receive timely reviews.
As you look back at the practices of other remote sensing or environmental journals, are there trends that you are seeing that help or perhaps hurt the effort to ensure the integrity of the scientific literature?
I think it's an important question, Steve, and one that I do have some thoughts about. When RSE began in 1969, it was the third remote sensing journal. Today, there are more than 20. It's quite appropriate and good that the number of journals has increased as the technology, science, and applications of remote sensing have increased. But I question whether our field needs or has been well served by all of the current journals. Why do I say that? In the 2018 Journal Citation Report, the statistics showed that the top 10 journals by impact factor published 83% of the papers and had 93% of the citations. Although not quantified like the JCR statistics, I worry that some journals are emphasizing speed to publication over peer review. My concern is that rejection by RSE or one of the other strong journals no longer means the paper will not be published, because there's always another journal wanting to fill its pages that will probably accept it.
Remote sensing science isn't that old, right? It's basically 50 years old, or does it go farther back?
Remote sensing actually includes photogrammetry. In other words, basically measurements made from, at that early years, aerial photography. And that got started back in with the advent of being able to collect quite a lot of good quality aerial photography in the 1920s, and people began to use it, develop those approaches. And there were 3 early journals that were really photogrammetric journals. And those techniques are now mostly all digital, and that's been a big advancement. But then also in more recent years, I think the most common, most widely used method of remote sensing is with digital multispectral types of data, ranging from Landsat to others such as AVHR and MODIS, Sentinel from the European Space Agency, drones for high-resolution imagery. So lots of different approaches and great data being acquired. Remote sensing, I guess, 1920s, late 1920s to now, it's about 100 years.
You were one of the early members of the Laboratory for Applications of Remote Sensing, known as LARS, at Purdue University, and that lab was instrumental in establishing and pushing the state-of-the-art in quantitative remote sensing.
Now, I had the good fortune to join LARS as a research agronomist in June of 1970 as Landsat 1 was being built. 2 months later, there was a major epidemic of southern corn leaf blight, and we were asked by NASA to look at monitoring its extent and severity in Indiana with digital multispectral data and color IR photography. The results were positive and led to the Corn Blight Watch experiment in 1971 that put together all the components of a system to acquire and analyze imagery to monitor its spread and severity across 7 Corn Belt states. LARS had a major role in that project, and then in classification of the first Landsat digital image in July 1972. The success of LARS was that it had visionary leadership and staff dedicated to developing a new paradigm for remote sensing, acquisition, processing, classification of digital imagery, first for aerial data and then for Landsat data. By the time I moved to the University of Minnesota in 1983, Landsat 4 had been launched, and the dream of William Pecora and many others of global mapping, monitoring, and analysis of satellite data was coming to fruition.
Well, I know that colleagues have said you are an unabashed fan of Landsat. Why is that?
I've often told students and others that Landsat is my favorite sensor. One, because it was being built as I started my career in remote sensing, but more importantly for the capabilities it provided for almost 50 years to acquire important information about environment and natural resources. The advancements in its spatial, temporal, and spectral radiometric resolution, new biophysical and radiometric models, and processing classification algorithms, along with faster and cheaper computers and the internet, are providing more detailed, more frequent, and more accurate information for mapping, monitoring, and analysis of Earth resources and environment, including monitoring land cover, crops, forests, wetlands, ecosystem health, drought, wildfires, water quality, and more.
So what's your assessment of the role Landsat has played in improving our stewardship of the Earth's natural resources?
Well, in short, I think it's been huge. Landsat data are being used for many applications and by many countries. A very important change in the Landsat program was when the data were made available at no cost by USGS and the Aero Center. It greatly expanded the R&D and applications around the world, enabling a paradigm shift from change detection to monitoring with the promise of near real-time monitoring. I'm looking forward to the launch of Landsat 9 next year and to the systems that follow it. More detailed, accurate, timely information that Landsat can provide are critical in the face of climate change effects, population growth, urbanization, ecosystem health, and many other aspects of Earth resources and environment.
When you consider remote sensing's place in the world of science compared to other science disciplines, should it be considered an equal to the others in its stature?
I'm probably rather biased, having spent my career 50 years now working with remote sensing. When I started at Purdue University in Lars, I thought, well, I'll try this out for a couple of years, see how it all goes, because it was somewhat of a departure from what I envisioned I would do with a PhD in crop ecology. But within just a few days, if certainly weeks, of starting at Lars, and then when we got involved in some of those larger crops projects, I never looked back. I said, this is absolutely going to be a valuable resource for collecting needed information about all kinds of areas and applications. So I just think I don't know what I quite say it's the equal of all other good scientific disciplines. There's a huge number. And it's not the largest discipline. There's many that are larger in terms of numbers of people working and numbers of papers they publish, et cetera. But it has grown immensely in the last, I'll say, 20 years as more and more disciplined people also found that adding satellite imagery and the mapping, monitoring, analysis that can be done with it can add to what they've already been doing with, say, field data. One good example is in the area of ecology. 30 years ago, there was only a very few, probably no more than 3 or 4, I'll suggest, ecologists who had figured that out or recognized that potential. And today, there are numerous ecologists around the world doing some excellent work with Landsat and other satellite imagery.
So what has, through time, the push for peer-reviewed studies, peer-reviewed literatures, the vetting of the remote sensing science, has it legitimized it even more? Or?
I think so, and I think added to its credibility. When I started, and for about almost 10 years, there was some major international remote sensing conferences that attracted a good number of people, and a large percentage of those working in the field at that time. I remember carrying home about 20 pounds from one of those symposia of papers. But in reality, that was gray literature, not peer-reviewed. A lot of that was lost. I think the peer review in journal publication, began to become more recognized as absolutely critical. Our discipline, remote sensing, needs to be doing that like some of the other major disciplines in chemistry, physics, mathematics, and many more. Pioneers in the field of remote sensing, as we now define it, started RSE, and then other journals followed, and I think that really led to the credibility and value of all of the work in the entire field that without that, I don't know where we would be.
We've been talking to Marv Bauer, the esteemed editor-in-chief emeritus of the premier remote sensing journal, Remote Sensing Environment, about fact-based science and how peer reviews help ensure it. Thanks for joining us.
Good to join you, Steve, and thanks for inviting me again.
We hope you come back for the next episode of Eyes on Earth. This is a product of the U.S. Geological Survey, Department of the Interior. Thanks for joining us.